And finally, so humans have pumped enough water from underground reservoirs to shift the Earth's geographic or rotational North Pole at a speed of 4.36 centimeters per year. Now, researchers published their discovery in an article in Geophysics Research Letters in June this year. And they discovered that from 1993 to 2010, humans displaced more than 2 trillion tons of water by removing them from underground reservoirs, which has caused this shift. But why is this important? Well, the axis of the Earth is spinning around, or the axis that the Earth is spinning around is a rotational or geographic North Pole. Now, this axis is relative to everything else in our solar system, and it's not perpendicular to objects, such as the sun, but instead is at an angle of around 23.5 degrees. Now, this tilt places the northern and southern hemispheres at different distances to the sun and produces summer and winter time. This angle can vary naturally from as much as 22.1 and 24.5 degrees, but over about 40,000 years. The largest changes in the Earth's axis occur seasonally due to the shifting motion of atmospheric masses as weather and seasons change, causing the geographic poles to wobble by several meters annually. Now, this movement of water, such as melting glaciers and ice caps, plays a role in water-induced axis shifts. However, in the last 2 decades, this change has been much more rapid. Since 2003, the axis has moved 78 centimeters. Maybe that doesn't sound like much, but this is entirely caused by humans. So how did we find this out? Well, when Seo and his collaborators tried to model the Earth's water content to account for how much the axis has tilted, they could not fully explain the data. Adding the effects of changes in surface reservoirs didn't help, so they looked at groundwater. Gravitational surveys have measured the depletion of underground reservoirs, which is caused in large part by irrigation, especially in northwestern India and western North America. These surveys show that groundwater pumping shifted enough mass into the oceans to cause 6 millimeters of global sea level rise between 1993 and 2010. By including these changes in their model, the authors calculated that they should have a substantial impact on the Earth's rotational axis, and they predicted that the displacement of groundwater alone causes a shift in the North Pole of 4.36 centimeters per year. Now, whilst the rotational North Pole normally does change by several meters within about a year, these changes due to groundwater, do they have that risk of shifting seasons? No, not really. But on geological timescales, polar drift can have an impact on climate. And this, combined with the rise in sea levels, demonstrates just how much of an impact and unintended consequences human activity can have.